Welcome to the course Machine Learning with Scikit-learn by Gavin Hackerling, a course by Pact Publishing. I'm Mark Thomas and I'll be the presenter of this course. This course will help you examine several machine learning models and learning algorithms. Gavin Hackerling is a data scientist and author. He's worked on a variety of machine learning problems, including automatic speech recognition, document classification, object recognition, and semantic segmentation. An alumnus of the University of North Carolina and New York University, he lives in Brooklyn with his wife and cat. Let's start with the course overview now. In recent years, popular imagination has become fascinated by machine learning. The discipline has found a variety of applications. Some of these applications, such as spam filtering, are ubiquitous and have been rendered mundane by their successes. Many other applications have only recently been conceived and hint at machine learning's potential. This course has a concept, example, code approach to get you acquainted with all Scikit-learn algorithms. The first section, the fundamentals of machine learning, defines machine learning as the study and design of programs that improve their performance of a task by learning from experience. This definition guides the other chapters. In each, we'll examine a machine learning model, apply it to a task, and measure its performance. Section 2, Simple Linear Regression, discusses a model that relates a single feature to a continuous response variable. We'll learn about cost functions and use the normal equation to optimize the model. After that, classification and regression with k nearest neighbors introduces a simple, non-linear model for classification and regression tasks. The next section, feature extraction, describes methods for representing text, images, and categorical variables as features that can be used in machine learning models. We then move on to the next section, from simple linear regression to multiple linear regression, which discusses a generalization of simple linear regression that regresses a continuous response variable onto multiple features. Section 6, from linear regression to logistic regression, further generalizes multiple linear regression and introduces a model for binary classification tasks. Then naive Bayes discusses the Bayes theorem and the naive Bayes family of classifiers, and compares generative and discriminative models. Following that, nonlinear classification and regression with decision trees introduces the decision tree, a simple nonlinear model for classification and regression tasks. The next section, from decision trees to random forests and other ensemble methods, discusses three methods for combining models called bagging, boosting, and stacking. Section 10, the perceptron, introduces a simple online model for binary classification. Section 11, from the perceptron to support vector machines, discusses a powerful discriminative model for classification and regression called the support vector machine, and a technique for efficiently projecting features to higher dimensional spaces. Section 12, from the perceptron to artificial neural networks, introduces powerful nonlinear models for classification and regression, built from graphs of artificial neurons. Section 13, K-means, discusses an algorithm that can be used to find structures in unlabeled data. The last section, dimensionality reduction with principal component analysis, describes a method for reducing the dimensions of data that can mitigate the curse of dimensionality. For this course, you need the latest version of Python and pip. You either need a Jupyter Notebook or IPython interpreter. Instructions for installing Scikit and its libraries are provided. So let's get started with the course.